The patented Merhes building system comprises of a method of construction using a prefabricated structural steel framework with preformed autoclaved aerated concrete panels supported contiguously to form the structural floor and wall between supporting steel frame elements in a building. The panels are delivered to site with preformed lifting holes to enable secure crane lifting singularly or in multiple panels in series by means of the respective lifting holes to enable simultaneous lifting of up to 5 panels. Contemporary multi-level construction typically involve the construction of a reinforced concrete structural core formed with the floors cast level by level, followed by erection of external walls tied into the structure. The process for constructing these concrete elements involves the fabrication of a complex formwork system, the placement of reinforcing bars with associated support props before the concrete is pumped and placed into each section and is allowed to cure until it gains sufficient strength. The formwork and props must then be removed before the internal elements and finishing works can proceed. This method of construction has proven to suffer from a number of significant and inherent disadvantages. Firstly, a large number of separate trades are required to implement the highly labour-intensive process that must be carefully coordinated. The overall process is inherently slow. In the context of a high-rise building development, the cumulative time required can amount to many months, at an economic cost of many millions of dollars for a single construction project to both the builder and developer. The Merhes building system is primarily devised to overcome and substantially ameliorate the deficiencies of the traditional method of construction and to provide an alternative form of construction for multi-level residential apartment buildings, retail shopping complexes, hotels, high-rise office blocks, schools, hospitals, and other forms of commercial and industrial complexes. It comprises a method of constructing a building by 1. Erecting a series of vertical and horizontal support steel columns and beams that are bolted, welded or otherwise fastened together, either on site or to be delivered to site as prefabricated structural subassembly. 2. And positioning prefabricated structural panels comprised of a reinforced autoclaved aerated concrete material that is placed in a side-by-side relationship to form a structural floor and wall. The spaces between adjacent edges of respective floor panels are tied together by reinforcing bars placed longitudinally in the channel. The channel is then grouted to form the seamless structural floor. The external wall panels are similarly positioned side by side to form a wall section extending between or adjacent the structural columns and beams. The floor and wall panel is hoisted into position utilizing a single centrally located preformed lifting hole and building attachments to facilitate the lifting of the panels to the appropriate floor level in the building structure. Depending upon the size and weight of the panels, multiple lifting holes and associated lifting attachments and linking elements may be used. The lifting formation includes an eye bolt having a head with an integral lifting eye, engaging a mechanism on the motorized carriage assembly of a wire rope, cable or chain, terminating in a hook formation on a rail traversing mechanism with guide wheels rolling on the lower flange of the I-beam to progressively raise and lower the suspended panel by remote control. A typical building project using conventional techniques would usually require around 60 to 100 workers on site. By contrast, A comparable building project optimized and constructed in accordance with the Mersey's building system may typically only require 8 to 10 workers during the corresponding construction phase. There is a significant reduction in weight of the building structure through the use of the structural steel framework and AAC structural panels, which produce flooring or walling that is substantially lighter than an equivalent area of conventional reinforced concrete, which contributes to further cost savings in terms of both material utilization and construction time. The independent quantity surveying firm Hayman Cohen was commissioned to produce a structural costs comparison report for a 9-storey residential apartment block at Rose Hill, Sydney, that states in their conclusion that there is no doubt that the Mersey's building system delivers a far superior end product from a multiple point of view. The financial benefits alone make the Mersey's building system an extremely strong candidate as an alternative building system to the more conventional concrete framed structure. The Mersey's building system is a superior building system that delivers financial, time-saving and a multitude of other benefits that cannot be achieved using conventional building methods. It can be seen from the report that there are potential cost savings of up to 13.7% of the construction costs to the builder and a massive saving of up to 28 to 30% of the construction costs to the developer builder.